Ladies and gentlemen, boys and girls, you have a once-in-a-lifetime opportunity to be the first audience to witness the finest Nano juggling show ever known. The amazing Nano brothers are two of the best jugglers on the planet and possibly the entire universe. These amazing Nano brothers will now attempt to juggle on this stage of the greatest science museum in the world 8 bowling balls, 15 flaming torches, 21 ears of corn, and 2 extremely cooperative elephants. Never before seen on this stage or anywhere else, this fantastic opportunity can be yours, but only if you can make enough noise for their little Nano ears to hear. Come on, everybody, let's clap and chant. Nano, Nano, that's it. Really loud, in the back. Nano, really loud. Keep it going. Yeah, yeah, it's working. Yeah. I can't believe it. It worked. You did it. Can I get a drum roll, please? Yeah. That's it. Really loud. Ladies and gentlemen, children of all ages, it gives me great pleasure to introduce the unrivaled, incomparable, amazing Nano Brothers Juggling Show. Thank you.
Joel, what?
Dan.
Oh, what are you doing? Not the amazing Nano Brothers.
Well, yeah.
Oh, now, can you folks see anyone on top of that ridiculous little stage there? Joel, you know, human beings can't see things in the nanoscale. A nanometer is a billionth of a meter. That's a billionth of this.
I know. Don't worry, it's such an awesome show. This time I came prepared.
You did you?
Yeah. I brought one of these.
Oh, boy.
A magnifying glass, huh? Check it out.
Joel,
All right,
Joel,
just
listen.
give me a second.
Joel, it's not going to work. Nano is way smaller than what you can see with a magnifying glass.
Okay, Mr. Know-It-All. Don't worry, folks, I saw something back here. Let me get it. Just a second, Dan.
Listen, everyone, I really apologize. You see, my brother Joel here has never been considered the sharpest tool in the drawer, if you get my meaning.
This should do it.
Oh, no.
Good thing it's a science museum after all. Just give me a second here, folks. I'm going to focus in on the...
Joel, I'm trying to tell you...
Wait, we're going to have to do this single file. Can you guys come line up?
No. Everybody, please remain in your seats. I still don't think Joel is quite clear on how small a nanometer is.
You mean this won't work either?
No, Joel, that microscope only magnifies things to about 100 times their size. That's enough magnification to make something maybe the size of a flea look like the size of a rat.
Oh, wait.
But nowhere near enough magnification to see something measured in billionths of a meter.
Well, how much magnification do I need to see something measured in nanometers?
Well, a billion. That's 100 divided by 100 divided by 100 divided by 100 divided by 10. That's 10 to the negative 9. That is a decimal point, 8 zeros and a 1.
Dan, no microscope is that powerful.
And that's why you can't show these folks the amazing Nano Brothers Juggling Show. A nanometer is smaller than a wavelength of visible light, so you just can't see it.
Sorry. Oh, well.
Hey, where are you going?
Well, I guess if you can't see him, the show's over, folks.
Well,
Sorry.
Joel,
you know.
just promised all these people a juggling show. Well, maybe you and I can make it up to them somehow.
Oh, okay.
Here.
Yeah. We know some stuff.
Yeah.
Don't worry, we've got some juggling.
Take these.
All right. I mean, sorry, Dan, but it must be such an awesome show, especially the part with the flaming torches and elephants.
So you can't shrink flaming torches and elephants to the size of nanometers.
But their posters said they could.
But when did you become such a sucker for advertising? That's just plain nano hype. Nothing is that small except atoms and molecules.
Atoms and Montagues?
Atoms and molecules.
Who are they?
What are they?
Where are they?
Everywhere. All right, let's start with atoms. Everything is made of atoms.
Everything.
Everything. Like these clubs we're throwing back and forth, they're made of atoms.
Really?
Yep, and so is
Atoms?
this
You guys know
football.
that? Oh, wait. Dan, what? That football is completely different from these juggling clubs. You don't see Tom Brady throwing a club, right?
It doesn't matter. It's just a different arrangement and assortment of atoms.
Oh, well, what other sporting equipment has been made with atoms?
Well, let's see what we got here. There's a football. There's a few juggling clubs. How about a house plant?
No, Dan! Whoa! Dan, wait, that's too much stuff.
Clubs, a football,
it's too much stuff.
and a house
What?
plant.
No! Dan!
Come on, Joel. Living things
help
are also
me!
made of atoms.
Living things are made of atoms?
That's right, this is a lot of stuff to juggle.
Yeah,
isn't
it's
it?
too much.
Could somebody catch that, please?
Look out! Dan! That was my football!
Oh, I guess Joel's going to want the football back.
Yeah, that's
You throw
my
the football
football.
back here to me. Just throw it
Yeah.
right here to me.
Throw
Just
it right up here.
Right
Look
up.
out!
Yeah, just throw it any time.
It fits right in.
We got a lot of stuff made of atoms over here.
What else is made of atoms?
Well, how about a bird bath?
No, I was kidding, Dan.
Made of atoms.
Is this made of atoms?
Yes, it is.
Really?
You don't have to whip it out like that.
Dan, don't throw it so hard.
Oh, boy. Okay. Are you starting to get it, Joel?
Okay, house plants, footballs, clubs, everything's made of atoms. Everything.
Even this.
No, no, Dan! Oh, Dan, where'd you get this?
This is made of atoms.
Oh my God!
You guys didn't think you were going to see this today.
Dan, this is silly.
You don't like this? Okay, how about that?
Where'd you get that?
This and that are both made of atoms. Don't you understand, Joel? Everything is made of atoms.
Oh my
this,
gosh.
that, the stage we're standing on, the air we're breathing, even you and me.
You and me?
And them.
And them?
Yep, in fact, there's only about 100 kinds of atoms known, and they're all represented right here whoop, on this chart.
The periodic table of elements, the coolest chart on the planet. Oh, there it is, all the
Yeah.
atoms.
There they are. You know what, Joel, I think this calls for? I think this calls for the 6 Club Juggling Periodic Table of Elements tribute. What do you say?
Yeah.
On the count of 3, you ready?
This is for all the atoms.
Here we go.
Here we go. 1, 2,
3.
Are you there, Dan?
Right here.
Okay, you can clap now. Oh yeah. Ooh. Yeah. Check it out. Yeah. Ha ha ha. Woo. Thank you. All right. So
Thanks,
Dan,
Joel.
what's an atom?
I thought you'd never ask.
I just did.
Well, I'm glad you did, because that gives us an opportunity to show all these folks our brand new atomic model juggling routine.
A new routine?
Yeah.
What do I do?
Well, let's see. I need you to get that big measuring stick over there. And while you're doing that, I need to get a volunteer from the audience. Now, it doesn't matter who, it could be anyone, any age, any size. And, oh, right back here, young lady with the flowery dress on. Yeah, come on up here. Awesome. Come on right down here.
Come on up
All right,
here.
first, we need to make sure that you're the right height for the.
Hi.
What we need you to do. If you could stand up to our measuring stick. Let's see, you come in right at 1.3 billion nanometers tall.
Wow, can you believe it? Perfect.
That's exactly what we're looking for.
Nice.
Okay, what's your name? Marina. Everyone, I'd like to introduce our assistant for the next bit in the show. Everyone, this is Marina.
Marina! Okay.
Okay, Marina. What we need you to do is stand right here on the trap door. That's nice.
Okay, that's good.
I'm gonna hand
Right
this
there,
back.
Marina. Don't move.
Marina, we have something really important for you to do. What I need you to do is if you could put out your left hand and hold on to this one there. Yep. You can hold it up a little bit higher. Nice
There
and
you
strong.
go.
Okay, now Marina, you are holding the nucleus of an atom. Yeah.
Oh, wait, hold on, folks. Wait, stop.
What's wrong,
Dan, hold it.
Yeah.
You just said a nanometer is too small to see.
That's right.
So an atom is too small to see.
Well, yeah.
How can we be seeing something inside of an atom?
Well, Joel, this isn't an actual nucleus of an atom. You understand that, right, Marina? Yeah, this is a model of the nucleus of an atom. A bundle of protons and neutrons.
It looks like a bunch of plastic balls glued together to me,
no,
folks. It's not
Like
real.
I said, Joel, it's a model. This is a model.
You mean Marina is like a supermodel?
Oh, Joel.
Marina, no way!
Joel, look at
Can
Joel.
I have your autograph?
Look, what Marina is holding, is a model that represents the nucleus of an atom, which I will have you know is even smaller than a nanometer.
Which is a billionth of a meter.
You're starting to get it. Okay, Marina, we need you to hold this nice and strong right in front of you with both hands.
Okay.
Just like that. And this next part's going to get a little bit mysterious, so we're going to dim down the lights.
Well, Marina, are you afraid of the dark? I am.
Ready? Hup.
Okay. Whoa, okay. Wow. Whoa. Wow, Marina, don't move. Okay, Dan.
Yes, Joel.
So you and I, wait, Marina is being the nucleus.
That's right.
What are we doing?
You and I, Joel, are doing the electrons. You see, the nucleus of every atom is surrounded by a whizzing, zooming bunch of electrons, and they're moving so fast, it's hard to tell where one is at any given time. It's like an electron cloud.
Wicked awesome!
Yes, and as you can see, atoms are mostly empty space.
What?
Yeah, atoms are mostly empty space. Between Marina, our nucleus here, and the whirling cloud of electrons,
yeah,
well, there's just not a lot of there. As a matter of fact, if we were going to do this to scale, Marina could stand here in the middle of the stage, and you and I might have to throw these electrons from across the street.
Come on!
Or all the way from Fenway Park.
No way!
Or as far as Lexington or Concord.
You expect me to believe that? What's in all that empty space?
Nothing, just forces, I guess. And may the force be with you. Hup.
Hey! Hey! Right, here, take these. Wait, hold up, people, Dan. If everything's made of atoms and atoms are mostly empty space, that means I'm mostly empty space.
Well, yeah, I guess that's true.
Well, what about poor Marina here and our audience?
Well, yeah, atoms are mostly empty space, so I guess everything is pretty much empty space. But you know what? Let's give our nucleus a break. Can we have a round of applause for Marina?
Marina!
She was fantastic.
Thanks, Marina. Shake my hand. You were the best nucleus a bunch of whirling electrons could ever have. Now split.
Don't ever tell a nucleus to split. What are you trying to do, kill us all? All right, I tell you what. Let's you and I each be our own atom models. Here, you need to put that on.
I get to be a model?
Yep, that's going to be your nucleus on your chest there.
All right.
And your hands are going to operate the electrons.
I get to be a model.
That's right.
Does this shirt make me look fat? Is this okay? No, good, thanks.
Joel, what?
Just a minute.
Why are you wearing a tie? What's the tie for?
Well, if I'm going to be a model, I want to look good.
Oh, boy. Okay, well, here's your electrons. Here you go. Hup.
Ooh, yeah.
Ta-da.
Woo! Nice.
Yeah.
Dan, we have a technical problem here.
What's the technical problem?
The electrons are too close to the nucleus.
Oh, well, we're not doing
wrong.
this to scale, Joel. Your arms aren't long enough to reach out to Lexington or Concord. This is to show you something else about atoms.
Now what?
Well, you see, atoms are always in random, ceaseless motion. And the more heat there is, well, the more they move around. See, we're beginning to warm up, so we're beginning to jiggle around.
I see. So we're juggling atoms.
That's right. And the hotter we get, the more we move.
Wicked cool.
No, Joel, wicked warm.
Woo! I like to move it, move it. He like to move it, move it. You like to move it, move it. We like to. Yeah.
Yes, and Joel, sometimes two atoms get attracted to one another.
Wait, Dan, I want to be my own atom, okay? You're not my type.
Science, Joel. Joel, no.
Help me.
Like brothers, Joel. They get attracted like brothers. Yeah. And when two atoms get attracted to one another, they bond by sharing.
Okay. Sharing.
Yeah.
Oh, I'm good at sharing. Last night when I was going to the bathroom.
No, Joel, no.
You should.
No,
What?
That would be oversharing. You see, when atoms get attracted to one another, they bond by sharing electrons, like this. Hup.
Whoa, so it's one big jiggling, juggling, electron sharing party at the nanoscale.
Thank you.
Woo! Yeah. Nice.
Hup. Yes, things are really moving fast down there.
I'll say.
And you know what? If we're going to a jiggling, juggling, electron sharing party, I think I should be the one to wear the tie.
No, wait.
Don't you?
I'm the model. I wear the tie. Thank
I'm
you.
more the brains here.
I wear the
So
tie.
I think I should have the tie. It's
No,
got character,
Dan.
really.
I wear the tie.
It doesn't matter who wears the tie, okay?
I look better.
Now give it back.
Oh.
Now, as I was saying, things are really moving around down there in the nanoscale, even inside solid objects where lots of atoms are bonded together, like this stage.
Like this stage here?
You got it.
You're saying this solid stage is actually made of bonded jiggling atoms.
That's right, and if you'll remember, atoms are mostly empty space.
What? Wait, there you go again. Hold on.
What?
Dan, you just said this solid stage is mostly empty space.
Well, yeah, matter, stuff is mostly empty space.
Matter is mostly empty space, Dan. That's like saying this is mostly nothing. Well, it feels pretty solid to me.
Well, to us, it does feel solid, but you see, inside each one of those atoms, it's mostly empty space. Well, it's kind of filled with all the waves of those electrons.
I can't take any more of this weirdness,
Well,
Dan.
that's the weird and wavy world of quantum physics. But hey, let's leave the insides of atoms aside and move on up to the nanoscale, where we're dealing with bunches of atoms and molecules.
What a relief.
Well, I gotta tell you, Joel, it's pretty weird at the nanoscale too, and stuff just behaves differently than what we're used to at the human scale.
Now what?
Well, it would be very difficult to juggle at the nanoscale.
I was afraid that's where you're going with this. Why?
Well, for one thing, gravity really doesn't amount to much compared to other forces. It's pretty weak.
I thought that was only up in space, like in the space shuttle.
Well, yes, but in inner space too. You see, atoms and molecules are so small that they have hardly any mass or weight. They may as well just jiggle off in this direction as in that.
Oh no, Dan, that's terrible. Gravity is a juggler's best friend.
I know.
How do those poor little guys juggle with so little gravity?
Yeah, and Joel, there's something even worse.
What could be worse for a juggler than no gravity?
Oh, you're not gonna like this. Here, put this on. You see, Joel, it's incredibly sticky down there at the nanoscale.
Sticky?
Yeah, sticky.
I don't like the sound of that.
Well, things tend to stick to one another.
You mean like a booger sticks to my finger?
Kinda like that, but more like the way a gecko sticks to a wall.
Oh, Dan, get it off! It escaped!
Well, that's actually kind of fun, isn't it?
Help me!
Ooh, hey. Hey, does anyone else want to try? Oh, yeah? Here you
Wait
go.
a minute.
You can throw that right at Joel.
Wait!
Here you
Oh!
are. Some back
Hey,
here. There you go. You
careful.
look like you have a pretty good arm. Let's get over this way
can't
here,
believe
too.
this.
Here, you want to throw that on
Whoa.
Joel? Help
Right
him
here.
see how
Oh.
sticky it is at the nanoscale.
Man, look out!
There you go.
I
Throw
guess
that
I'm
right
really...
on him. Thanks. Perfect.
I got it!
Wonderful. Oh, sorry. Can you get that?
I guess I'm
Here
really
you go. Throw that
attractive,
right
aren't
on.
I?
Here you are, young man.
Oh, geez!
There you go.
Oh!
Here you go. A couple of guys over here.
Oh! Dan, I'm really attractive. I love this.
You love this,
Thank
huh?
you. Look!
You love this. Well, let me
I
just
like
do
it. I
a
caught
little
'em.
rearranging here. Put those there. Put this one here. All right. Try juggling.
Oh no, Dan, it's impossible! Those poor little nano guys, they don't get any breaks down there, do they?
Like I've been trying to tell you,
Oh.
it's really different at the nanoscale, which is the size of atoms and molecules, which are too small to be seen with ordinary microscopes, but everything is made of them.
Okay, it's starting to sink in, folks. This is what Dan just said. Teeny tiny things behave way differently at the teeny tiny nanoscale, which is the size of teeny tiny atoms and teeny tiny molecules. And what's a molecule?
I'm so glad you asked. Okay, a molecule is just two or more atoms bonded together in a particular way. Like when you and I were sharing electrons earlier.
Right.
For example, take an oxygen atom bonded together with a couple of hydrogen atoms. Well, that's a water molecule. Get a few gazillion of these together and you have yourself a drink of water. Or take a chlorine atom bonded together with a sodium atom.
Yeah.
Well, that's a salt molecule.
Yeah.
Get a few gazillion of these together and you might have a shaker full of salt. And then there's DNA. Now that's a really big molecule that carries the genetic code for making each and every one of us. It's made of millions of just 5 kinds of atoms: carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my!
Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my! Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my!
Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh my!
Carbon, oxygen, hydrogen, nitrogen, and phosphorus.
Oh boy! Okay, Joel, that's enough.
Okay. I get it now. Molecules consist of atoms sharing electrons.
Right.
Atoms consist of a nucleus in the center,
Neutrons and protons.
some whirling electrons, and a lot of empty space. Which is still a big mystery to me. How can anything be solid around here? Anyway, this nanoscale stuff is sticky. Gravity doesn't matter so much. These guys could be running around on the walls like geckos.
Yeah.
Anything else you want to tell me, Dan?
Well, lots, but I'll just share one more. Have you ever noticed how small things are more reactive than big things?
You mean like when a toddler has a tantrum? Mommy, mommy! That's reactive.
Different kind of reactivity.
Right?
But hey, let's try it this way. Why don't you juggle these for everybody?
Oh.
You gotta be careful with all those.
Oh, geez.
All right.
I get to do this? All right. Here we go. Check it out. This is good. Here it goes. Hey! This is boring, Dan. This is clumpy and boring, Dan.
I
They
couldn't
don't
agree
like
more.
it.
Well, let's see what happens if I break this up into smaller pieces. Here you go.
Oh, gee. Now they're in little
And one
pieces,
more.
and they're really reactive,
They sure
Dan.
are.
I think this is going to be a lot more fun. Let's see. Whoa! Yeah! Woohoo! Now that's the reaction we were looking for.
Like I've been telling you.
Ooh.
Ooh, very nice.
Thank you.
Smaller bits of the same material are more reactive than bigger bits.
You're telling me.
Ooh, very nice, Joel.
Woo! Yeah.
Wow.
Hey!
And Joel, I gotta tell you, things happen quicker down at the nanoscale too. Those guys, if they were doing a show, it would be over by now. Yeah, nanoscale stuff is small, and reactions happen very quickly, and sometimes in unexpected ways. It's like operating in a whole new universe down there at the nanoscale.
Well, but Dan, if you can't see atoms and molecules with magnifying glasses and microscopes,
Yeah.
how do scientists get an idea of where they are down there?
I'll show you. First, we have to pretend this place is cold, super cold. That way the atoms won't move around so much. Here, you better put these on.
Okay, I'm from New England. I know how to be cold,
Okay.
right?
And let's say
No
that
problem.
these are iron atoms on a copper surface.
Okay, iron atoms on a copper surface.
Right.
And I'm cold.
Let's see. Very convincing, Joel.
Oh, good.
And there's a nifty device to which a needle-like probe is attached. Let's say that that this big, tall unicycle is our probe, and you're gonna ride it. Hop up there, Joel. Go ahead.
Dan, you're crazy.
No, climb on up there. Look, it's just like riding a small unicycle once you get on the top there. You guys want to see him do it? Yeah! Come on, Joel. Come on over. I'll even hold it for you.
Dan, is it just like a little one?
Just like a small one once you get to the top.
Jeez. Don't move it.
I'm not moving it.
Okay, I'm going up.
Going for it. Here we go. 1, 2. All right, you're almost there. Okay, you're doing great. All right.
Your way.
Whoa. It's okay. I'm all right.
Oh, jeez. No, hold it in
Try
one
that
place.
more
It
time.
moved.
Hop
It
right
moved.
up there.
Ah,
All right.
I'm going up.
All right,
I'm
good.
going. No,
All right,
no,
you're
pull it
almost
your
there.
way.
All you gotta
Pull it
do
your way.
is let go of my hair.
Oh,
Right. And get your foot on the other pedal.
Dan, I want to get down.
No,
Dan, I
come
want
on,
to get
Joel.
down.
Get your foot onto the pedal. On the pedal. Almost. Okay. Now you just got to get your rear end on the seat there. Yep. Just
Okay,
jump
help me
right
up.
up
Help
there.
me up there. Help
Jump
me
on
up
it.
there. Help
There
me
you go.
up.
Okay.
Oh,
All right. You know what's gonna happen now?
square dancing?
No, we're not gonna square dance, Joel. Listen, I'm gonna count to 3. Okay.
Yeah.
This time. Oh, thank you.
Yeah.
When I say 3, I am going to walk away. Do you understand what that means?
I'm a dead man.
No. It means you have to keep the wheel moving at all times. Just keep going back and forth, back and forth.
Right,
You ready?
back and forth, back
1,
and forth. That's
2,
it.
3.
I got.
You're free.
No, wait, Dan.
What's wrong?
I can't do this, Dan. I'm scared.
Oh, you know what, Joel? I think you'll find that you're a lot less frightened and a lot more comfortable if you just don't look down.
Oh,
Don't look down. Okay, you
Don't
ready?
look down.
1,
Don't look down.
2,
Don't
3.
look down.
You're free.
No, Dan, help me. Oh,
Okay.
help, Dan.
Now, Joel.
Whoa.
Joel, you now represent the probe of a scanning probe microscope. And what we need you to do is scan back and forth over the surface and try to find the iron atoms. Remember, don't look down.
Dan, How am I supposed to find the iron atoms if I can't look down?
Well, you have to feel them. When you feel a kind of a bump.
Whoa!
Yeah, right
whoa,
there.
I felt it.
Yeah, that bump indicates that there's an atom underneath the tip of your probe.
Whoa!
There you go.
I felt some bumps.
Cool.
So what does this tell us,
Well,
though?
here, take some of these. Here you go.
Oh, what are
And
these
you're
for?
gonna need well, these, Joel, represent the ones and zeros of computer code, and you need to send them to me as data.
What data?
The data about the atoms you're probing with your tip there. Go ahead, scan around, try it. Remember, don't look down.
Okay, don't look down.
That's it.
Don't look down.
And then
Whoa,
send me the
Dan!
data. That's it.
Whoa!
Awesome.
Did I send you some?
Yeah, and another.
It works, Dan. It's working.
Cool.
All right. Do you get it? I scan blindly over the surface, feeling for bumps, which represent the force of the atoms, and then I send the data to you.
That's right. And pretend that I'm the computer. You know, the brains of the operation.
That's a stretch.
Well, you're the one who wanted to know how scientists can image individual atoms. This is how.
What, by riding unicycles and juggling in front of live audiences? What, are they crazy?
All right, calm down there, Joel.
Is this what my science research tax dollars are going to?
No, Joel, this is a metaphor. It's an analogy.
This is a pain in the...
As I was saying, we are pretending to be a scanning probe microscope.
Right.
A sophisticated device that can sense the tiny force fields of individual atoms through a fine needle-like probe. That's you.
Yeah.
Send enough data back to the computer, that's me, and we can draw an image of the atoms on the surface. Now,
Cool.
back here, I have an entirely different arrangement of atoms. Well, these, Joel, represent xenon atoms on a nickel surface.
Okay.
And let's see if by doing a little bit of probing, we can figure out their placement. Here's some code for you. You're going to need to send that to me as data.
Okay.
Remember, Joel, don't look down.
Oh, jeez. Okay, I'm lining up my probe, folks. Here I go. Tell me when I'm ready.
That's right. You got to come a little
Am I
bit
good?
closer. You'll feel it.
Whoa, whoa,
Feel
whoa,
it?
whoa, 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 here it comes.
Okay, let's probe.
Here comes the data. All right, I'm feeling it. Whoa, there's a touchdown here. Yes! Hey, we got it. Okay, Dan. Dan, what do we got? You're supposed to spit out the picture of the data we can see, right?
That's right. And this is what we got. Ta-da! Oops. Ta-da! See, Joel? Yeah.
What?
IBM.
Huh?
Yeah.
You be Dan.
No, Joel. IBM. Don't you see? These
No.
atoms are arranged to spell IBM.
Wait, you're just saying that we happen to find some atoms arranged into a corporate logo. That doesn't happen in nature, folks.
No, it doesn't, and that's just the point.
What do you mean that's the point?
Well, you see, the people who first learned to image individual atoms using a scanning probe microscope
Yeah.
decided to arrange them so they spelled out IBM. In fact, here is a picture of some of the images that they got.
Whoa, sweet!
Yeah.
Were they trying to get a job there?
No, Joel, they already worked there, and they knew, just like you, that no one would ever believe that nature just created a pattern like IBM on its own. So people would have to believe them when they said they could move around individual atoms.
So they used a scanning probe microscope to not only image, but move atoms.
You got it, and they did it over and over again in exactly the same position to prove that they had precise control over the placement of the atoms on the surface.
Cool.
Yeah. In fact, here's a picture of one of those folks right here.
Oh, let me see. Dude, all right. Was his name Adam?
No, Joel. His name is Don Eigler, and he did this back in 1989.
Well, imagine that. A corporate billboard at the nano scale.
Pretty cool, huh?
Dan, you know, these guys would love that. I bet if I got my unicycle up on this stage and send you some data, we'll see the amazing Nano Brothers.
Joel,
Give me a second.
I gotta explain
Here
one
I go.
last
I'm
thing.
going
to you.
up,
Joel,
Dan.
the amazing Nano
Whoa.
Brothers, Joel.
Let me up.
They're not actually on that little stage.
But-
They're not there.
But-
They're not.
You kidnapped them.
No, Joel.
Call 911.
No,
CSI.
no.
Look, get out your cell phones.
Joel, they're not there.
Give me the Nano Brothers.
They never
Where are
were
they?
there. Joel, they never even were there. They just couldn't exist without breaking the laws of physics.
They're not really there.
No, Joel.
They were never there this whole time.
Sorry. Well, now do you understand that nothing can exist at the nanoscale except, well, atoms, molecules, and nanoparticles?
I guess so. No amazing Nano Brothers.
Well, that's not entirely true.
It's not?
No, you and I just did a whole juggling show about Nano. We're the amazing Nano brothers.
That's right! Thank you!
Yeah,
That's us!
that's us.
But wait, I just thought of something.
What's that?
Does that mean some big Godzilla thing's gonna come running over us with a scanning probe microscope?
No, but it
Look
does mean we
out!
better show these folks some kind of big juggling finale. I tell you what, why don't you do a quick review while I get on my unicycle?
Oh, okay. I'll do a review. Okay, folks, I bet you didn't know there's gonna be a pop quiz. All right, now just shout out the answer. You don't need to raise your hand. First question, how small is a nanometer? Billionth of a meter. Very good, too small to see. What is everything made of? Excellent, even you and me. Very good. What are atoms made of?
Protons and neutrons and a lot of empty space.
Oh, I hate that one.
And Joel, what is the name of a device that can be used to not only image, but move around individual atoms?
A unicycle,
No, Joel.
right? Oh, no, wait. A scanning probe
A
microscope.
scanning probe microscope, and here's the important point.
Yeah.
When people started to be able to move around individual atoms and build things with them,
Yeah.
that was the beginning of nanotechnology.
Nanotechnology, I've heard of that. The manipulation of matter at the nanoscale.
Ooh, pretty good there, bro.
Huh?
Hey, Joel, you better reach behind the backdrop over here. There's a few things that you need to get for our finale.
Okay.
Yeah.
Excuse us, folks.
You should find a tennis racket
Yeah,
and a tennis ball.
I guess we're playing some tennis here, folks. I hope you
Joel,
don't mind.
We're going to juggle these along with these baseball bats for our finale.
What?
Yeah, you see, Joel, all of these
Oh,
are
no.
examples of products that have been enhanced using nanotechnology. The manufacturers have actually worked carbon nanotubes into these babies to make them stronger and more resilient.
Jeez. Well, what other sporting equipment has been enhanced with nanotechnology?
Joel, sporting equipment is just the tip of the iceberg. Nanotechnology is being utilized in everything from solar panels to computer equipment, medical devices, even big flat screen televisions.
I'm not juggling a flat screen TV, especially mine.
Well,
right?
I'm not juggling an elephant, flaming or otherwise.
Right.
Let's keep it small.
Yeah, and let's keep it safe, Dan.
Oh,
Okay.
yeah, that reminds me. Kids, children, please remember this. If you don't remember anything else from all the tricks you saw my brother and I do this afternoon,
Kids, listen.
remember these words of advice. Kids, don't try this at home.
Right, kids? Go to your friend's house.
That's how we learn. You ready, Joel?
Ready.
Here goes.
Hi-ya! Oh, jeez. Yeah. Yes. Yeah, they did it.
Ta-da!
Woo! Wow. Thank you.
Thank you, ladies and gentlemen. Once again, I'm Dan. This is my brother, Joel. We are the amazing Nano Brothers. We really appreciate you coming out to see the show today, and enjoy the rest of your visit to the Museum of Science.
Thank you. Thank you. Thanks for coming. Woo.